So in this video, I want to look at graphs that are representative of constant acceleration. And so some of this is review and some of it I'm just pointing out a little bit more in detail what you might need for your lab. So if something is accelerating, we have a position versus time graph. That means that the velocity is going to be steadily increasing, right? And as we do this, as we demonstrate that, we will have a curve, right? And remember, the slope of a position versus time graph gives us velocity, and so we can see that the instantaneous velocity would be then the line tangent, and so as time goes by, we have a change in that velocity causing acceleration, and an increase in the velocity, which you can see by the slope. Now, if we're going to then take that and transfer it to a velocity versus time graph, well, here we're having a constant increase in acceleration, so it's going to be a line. Okay? And then if we wanted to then look at an acceleration versus time graph, which we won't look at too often, I'll give you some examples. It's not as common. We're going to have some positive constant acceleration. So those shows those three graphs. Now, I want to kind of look at this graph in particular because I have derived some constant acceleration equations for you, and one of them is a quadratic equation, right? Where d is equal to v initial t plus 1/2 at squared. And this quadratic is where we get this parabolic graph, and you'll see it in the lab if you have not already. And what's important to recognize from this is that we can solve, there would be two different times, right? So let's say I threw something up in the air, right? It would create this parabola, and there would be some time here and some time here where it would cross, which is why it's t squared, and we get two answers for this kind of equation. And we'll see this more too when we do more projectile problems in the next unit. So in the lab, you're actually going to have to look at what the letters in the quadratic actually mean. So remember, you get a x squared plus bx plus c, right? So that is your quadratic in order to plug into the quadratic equation. And remember that the a is right before the squared term. So a in the quadratic formula is going to be actually 1/2 of our acceleration, whereas b is going to be the initial velocity, and then c would be represented by this displacement. Now, since I'm talking about the quadratic, it may have been a while since you have used the quadratic formula, so I'll just mention it here in case you've forgotten it. It is the opposite of b plus or minus the square root of b squared all minus 4ac all over 2a. Right. So this is the quadratic formula. Right, so that should be just a little overview of constant acceleration and just a little bit more information that you will need going forward in solving these types of problems and completing your motion analysis lab.